And we're reviewing. So let's get this on desktop here. I'm going to make a review sheet along with you guys, and then we'll put it in the cohort repo. So we'll make like a markdown sheet of information that's valuable, worth studying. What did we learn in these past 2 weeks, right? So we'll call it the Point Study Guide. That looks better. Okay, first thing, let's start with the perhaps pain points for some people first. Let's get that out of the way. Python. Okay, what do we think are things that we need to be able to do with Python? What are the first things we learned with Python to do?
Functions.
Sorry?
Functions.
Functions. Cool. What are the first things we learned in Python, like when we started, like on Monday, like last week? What did we write? What did we get Python to do for us with the command line?
sysrv.
Right. Yeah, we started using that sys module. So you need to be able to, at this point, get command line arguments, right? That's important. Let's talk about how we do that. Import sys, you said it. What about if I wanted to get a list of the command line arguments? Get list of arguments. How would I do that?
Print sys argv bracket 1 and
sys.argv. And yes, bracket 1 slice, right? Don't get the 0, grab all the arguments, being able to do that, right? Good times. You remember when we first learned it. What if I want just the, nth argument?
:2 -1.
Sure. Like it. What do you mean :2 -1? Actually,
Like print sys.argv bracket nothing in there, and then parentheses, then -1.
So what'll this do?
Well, with the colon, I'm sorry.
With the colon?
Prior to the 1. Yeah.
Prior to the 1. So you want :-1?
Yes.
What'll this do?
Gives us the last argument.
But I want
Give
the
us
nth.
the whole thing, right?
I want the nth argument.
What do you mean by the nth? I'm sorry, I thought that meant last.
Oh no, like 1, 2, 3, 4, n.
Just the index number.
Yeah, that's the index number. So it'll be n+1, honestly. Right? Or really just n. Sorry, didn't want to make it confusing. I'm just saying, like, if you wanted the 5th thing, you would put 5 in there. If you wanted the nth thing, you would put n in there.
Actually, I didn't think variable, sorry.
Yeah, no problem. Cool. I think that's all I want to say about that. What is other things that you want to be able to do with Python and why Python is great, right? The reasons Python's great and useful is you have string manipulation, right? It's much easier to do that when you can use F strings, when you can slice, when you can use index of or like find, right? Anytime you want to do things with strings like that, you want to be using Python. You want to be thinking like that. Python's great because we have more advanced ways to store our data, right? Data structures, right? We had lists and dictionaries, right? If I need to store things in key value pairs that I need to look up later, gonna want to use Python for that, right? Bash just doesn't give me that functionality that I want. So if I need to use advanced data structures, going to be using Python. And that means you guys should be familiar with how to loop over lists, loop over dictionaries, access items from lists, access items in dictionaries, both the keys and the values. And then the last thing that's important, for the exam will be Python requests. I went through the exam this afternoon, and I think there's only one Python problem on Tuesday that will require you to use Python requests. And I think it's a bonus problem. So that'll give you an idea for the level of Python that's going to be required for the exam. Not that much. Okay. So that's as much Python. Let's talk about other important things and big things that we learned, right? How the internet works. That's huge. Should have changed how you think about how the internet works. So first thing I want to talk about are DNS queries. What do you need to be able to do? Forward lookups, verse, CNAME, etc. Right? Any of those things, be able to do them. Be able to do them in host, dig, and NS lookup. I'm not saying you actually have to do it and be able to do it with all three on the exam, but I'm saying you should at least feel comfortable with being able to do it with two of them, right? Have one that's your favorite and one that's just in case it doesn't work that you'll try, okay? You want to be comfortable with all of them. So what can we talk about with DNS? Give me a brain dump. What port's it on for starters?
53.
53. Generally, yes. Is it a TCP or UDP? Is that a TCP or UDP port?
UDP.
Yeah, UDP. Can be on TCP too, though. Let's see. What does DNS actually do? Like, how does it make my life easier?
Resolves a
Domain name
domain from the IP address.
Yeah. All right. Good. Everyone's saying it, right? Resolves domain names to IP addresses. So I don't have to remember IP addresses. I just remember domain names, right? Very important. It matches up with that availability concept that, right, is part of our jobs, right? Making sure that services are available. They're available because DNS makes it easy for people. Okay. Cool. So the DNS crucial to the internet. Next up, we have the second most important part of the internet, right? Which is HTTP. Right? HTTP verbs. What are the big ones?
Get, post, delete, put.
Yep, CRUD. That's very common with all sorts of programming and yeah, really with programming. Most people, the first app that they build is a CRUD app, not like CRUD like bad, like CRUD, create, read, update, delete. Those are the most core functions of what's going on here. And we map them to the same idea here with HTTP verbs. So we have create, read, update, delete. Those map very nicely to the HTTP verbs get, post, let's do post, is create, put is update, and delete is delete. Wow, clever.
Something feels wrong with that last one.
Right, it doesn't. I feel like we should have something shorter somewhere, but I wasn't around or clever enough to come up with a better name or be there to even get asked. But yes, right. Important things we want to know. What's the? I keep repeating this, but what's important about GET requests? What do they not have?
A body.
Yeah, GET request. No body in the GET request. So how do GET requests? If I want to send information, but I'm only sending a GET request, how can I send more information? There's no body. What can I do? Have, I think, much two answers. And they're both in the same place in your browser. I'm trying right now. I'm going on a website to see if I find a good example. How can I send information through a GET request?
Can you send it as data?
So I can, so there's no body in a GET request, right? So where can I send information?
Send it in the header.
The header.
Can some, so some, the header is some, yeah. Header, so we can send some metadata. Metadata gets sent in header. What other data? Ooh, that looks wrong. Let me put it.
Can you do URL encoded?
I like where you're thinking. So where do things get URL encoded, I guess? I'm trying to find off of this website a good example right now. Get some URLs. There we go, found one. Cool. So let's say we go on shopping. It's black. Oh, I can't make this top part larger, unfortunately. But here I have bonobos.com, right? It's a clothing state off of HTTPS. So one place I can send information to the server is in the URL. I'm asking, right, bonobos.com for the resource at shop clothing lounge dash sleepwear. Right, so in the URL right there, that's one, the path of the URL. But the second part, the second way I can send information in a GET request is called the query parameters. And these, and if you look in a URL and you'll start noticing it, I want you to pay attention when you're just doing your regular browsing. When you look in the URL and you see that question mark is the sign that everything after this is query parameters. And they're usually to kind of filter down your request to make it more specific. Right, so if we're reading this URL, it's like, yes, I'm asking for all of your sleepwear that's under clothing, that's under your shop. But you'll also notice here, it says base color equals blue. So I'm adding additional information in the request. And this is one way you can add additional information specifically in GET requests, is URL query parameters. So pay attention to them as you get them. They're again marked by a question mark. And after the question mark, it's like key equals value. And then if I wanted another one, it would be like ampersand and then like key equals value. So that's how you can send more data. The only two ways. So query parameters in the URL. Everything after question mark. Let's do question mark like that. Question mark. Okay. Posts and puts. What do we want to say about them? I don't think there's anything too big, but again, metadata gets sent in headers. And both of these guys have bodies. Have a body to send data. You know, could be form, URL encoded, could be, you know, JSON, right? There's different ways we could send data. And I'm just going to copy this for both post and put. Because it's the same. Ah, what have I done? Tab there. Okay, looks good. Delete. What do we want to say about them? Usually doesn't have body. Okay. What do we want to say about each of these different HTTP verbs as far as authentication? Which of these should be authenticated? Which of these it doesn't matter as much? Should I just be sending unauthenticated delete requests that servers are like okay with?
It would be everything but GET.
Pretty much. And then even GET sometimes. Even GET sometimes, right? You can imagine you shouldn't be able to get everybody's Google Sheet. So yes, I agree. Let's do. Just, I like the simple answer. Everything but GET needs authentication or should have. Let's say should have, right? Because we could think of maybe some situations, you're building some crazy app where, you know, everyone can post and everyone can be random and people can change each other's posts or something. Maybe you're making an app like that. But for everyone else, right, for most things, everything but Get should have authentication. Sometimes Get should have too. I think that's a good way to think of it. Okay. Let's see. What else can we talk about for HTTP? There's a lot of stuff here. We talked about the verbs. So what type of data are we getting generally? What type of files? We're getting them over HTTP.
HTML.
And
CSS.
I heard two things. I heard CSS files. How do I want to write this? Files for a website. Let's do that. I heard HTML. Right. I
We
heard.
get images too, like PNG.
Yeah, we can. Let's talk about the. All right. Well, I'll add those. I'll add PNG. I'll add it. I don't hate it. We do get PNG over the web, but I don't need it. I guess I don't need CSS either. What's the other big one?
JavaScript.
JavaScript, right? That one's big. So let's talk about what they do. What is HTML?
It's a markup language.
Yeah. Markup language, right? It's like these markdown that I'm writing right now, right? I'm writing markdown so that way you see it on this side. So it kind of like looks kind of nice. HTML is another markup language, right? It's the content and it's metadata. What's the CSS?
Style sheet.
Style sheet. Yeah. Tell me what it does.
It's like the accessories.
Be more specific.
It dictates how the page looks.
I like that. Dictates. I like that answer a lot. Dictates how a page looks. Really, it's as far as you guys need to know, it's just a set of rules for how things should look. Right? Not super interesting to us as security folks. I can't think of any weird vulnerabilities where there's some kind of code injection in it. So, you know, not for us. Now, tell me about the JavaScript.
It's how you interact with the website.
Yeah. Well, I don't want to say how you interact with the website, but I like the path that you're going. How can we improve that answer?
Lets you interact.
Lets you interact. I feel like I would say
He
like the
makes
browser.
the website interactive or dynamic.
There we go. Makes website interactive, dynamic. I like this. I think this is our best answer yet, folks. For what JavaScript does, right? It's the logic behind the website. It's like when you click this button, it's going to open up. When you click this button, you're going to send a request there, right? It's all the logic necessary for Facebook to be updating your feed and Reddit to be, you know, having never-ending scrolling and all of that stuff. And it's really some of the biggest part of the website. A lot of the code, right, that people are writing isn't really HTML or CSS. It's mostly the JavaScript. That's the biggest part. And that's also part that's going to be most interesting to us. Understanding JavaScript, understanding how people write it, understanding, you know, the libraries that developers use, right? That's like, you know, how we have to understand our target and understand how people use this technology so we can see how people break it and the bad things they do. And yes, I'll add, so PNG, you know, JPEG, GIF, you know, etc. Of course, other files come through the internet as well. I'm not going to put them. I'm just going to say those. Okay. What else do we need to add? So we got the files of a website. How does a website remember who you are?
Cookies.
Cookies.
Yeah, cookies. So let's talk about HTTP protocol. Right, big thing is cookies for state. Right, HTTP is stateless. So the protocol by itself does not account for, you know, you being logged in. It forgets every time you send a request. right? We already got to bang our heads against the wall for a few hours because we, weren't sending cookies, needed to use the session thing from Python requests. So, that's the point. Drill that home. When you delete your cookies, you lose all of those temporary kind of credentials. And if you steal someone else's cookie and you know what website you can use it on, you can impersonate someone else, right? Stealing cookies can be dangerous. There's pretty good, I think, Darknet Diaries episode on credit card skimming and the digital analog of it. Digital analog, I love saying that. But essentially, getting some code onto a website that might be taking credit card information, and then sending that information or stealing those people's cookies, and sending them to some server and then using those cookies for nefarious purposes. Anyway, so we got cookies for state. Right, that's on the client side. What do we call it on the, what's that little database that the server has to remember who you are? You know the name of it.
Is it the session?
Yeah, you got a session. Developers know about it, right? They have all this software specifically for handling that part of your website so people can stay logged in. But yeah, it's the session. That is you could think of it as the server's database for remembering who you are. Maybe it's like you can think of it as their code check, the actual where they put their codes. Okay. Other things that are important about HTTP that we got to remember: one request equals one response only and forever. That's just the way the protocol works. This is usually more annoying for web developers when they're trying to make their web servers push out information to people, and we're like, sorry guys, the HTTP doesn't work that way. But for us, it's still important to know one request, one response. How do we deal with encryption for HTTP? Tell me as much as we do know. What's the difference between HTTP and HTTPS?
Different port.
Security.
Encrypted and non-encrypted.
I like it. So I'm trying to try and capture all those things. So we have HTTPS uses encryption, right? HTTPS uses port 443 by default. We can say that this is TLS. And we can say that it is, actually, we'll talk about encryption a little later. I think that's about as much as we need to know for now on the differences between HTTP and HTTPS. Everything else about them is the same. Biggest difference is the port that they generally will run under, and that HTTPS is going to be using a service before it sends, or using a protocol before it sends the data, called TLS. So it's going to wrap everything up so that you can just see who it's going to, but you can't actually see the data that's being sent. Right? That's the major difference. Everything else, one request, one response, still cookies, still sessions. Okay. Other big things, other big topics, huge topics like networking, right? How do we think about computers talking to each other so we can go about debugging things, so we can go about attacking things, right?
So Matt.
Sure.
What about the response codes?
Oh yeah, let's add those. Yeah. HTTP response codes. So what have I told you guys to remember? I'll give you one. 200s equal okay. What are the
300s was redirected.
Redirection, some kind of redirections. 400s.
Was that error?
What kind of error? Whose fault?
Client side.
Client side.
Yeah.
Client side error, right? Think 404s. You're asking for a resource that we don't have. And then 500s are
Server error.
server
Broke it.
error. Server error, right? You broke something. As far as you know those, you're good. Good, thank you. Other things for responses that we're interested in? I don't think we're too interested in like the response headers. Be aware that responses also have headers. Be aware that responses will have like a set cookie header if they're telling you to set a cookie. But I think that's all I want to add for that. All right, let's go to the OSI model. No, I don't need all caps. So what is it? If you had to explain this to, your little brother, your little sister, your grandma, whoever, how would you explain it to them in like 1 or 2 sentences tops?
It's a model that was created to break down the way the internet traffic is processed.
Like that. I like that. Model for breaking down how traffic between machines is processed. I changed your wording a little bit. Is processed and transferred. Maybe not processed. I'll say transferred. Okay. What else can we say about it? How many layers? It's like a delicious cake.
7.
Right?
7.
7 layers. I'm not gonna. Actually, yeah. Let's go through them. What do we got at the top?
Application.
Application. All right. Let's talk about some protocols that live here. What are some application protocols?
HTTP.
I guess I'm glad someone got the easy one. What else?
SSH.
Was that?
She said SSH.
Heck yeah, right? SSH application layer. I like that.
FTP, I think.
FTP's application. I'll throw an etc in there because there's a whole bunch, right? These are the applications people are working with. That's why I will say layer 8 is the people layer, right? This is where people be. Layer 7, we have the application. What's right below application? Presentation. And what does the presentation layer do for it?
Presentation organizes the data, I think, right? Makes it viewable.
Yeah, makes it viewable. What else?
That's the encoding decoding layer.
Right, encoding, decoding, encryption. Okay. Gosh, can't type. I'll give you a session. What do we want to put as session? I don't really like these 2 layers as much because we don't interact with them as much. We have, I think encryption goes here too. We can put session. So session, you might have some APIs. Not too much that we're going to be dealing with. And this is why I usually reference that TCP IP model. A lot of the stuff we're going to be doing with is not in here.
I have a question. Did you add encryption to differentiate it between encoding and decoding?
Mm-hmm. Yes, there's a difference between.
Yeah. Sorry.
Yeah. No, good question. Good question. It is tricky. So just so we're all clear, encoding, decoding is just taking data in some form, putting it in another form without the intention of hiding it. And then encryption is with that intention specific. Cool. Important distinction. Next up, transport. What lives at this layer? Is the easiest thing to think of, I think. Or what 2 protocols?
TCP and
UDP.
TCP, UDP, right? I generally think of this layer as the port layer, right? Here's where your ports live, ports of the machine. And below that,
Network.
right? This is really just the IP, and it's the IPs live here too, right? So there's the internet protocol right here, and your IP address. This is what you can think of when we're talking about that. Below network.
Data link.
Data link. What form of reference to machines lives here,
MAC address.
right? I got the MAC addresses. And finally, the physical layer, physical. And this is, you know, the actual physical stuff. So your signal, you know, hardware, wires, etc. All that stuff lives there. Anything I want to add? I do want to add about TCP versus UDP. Does it make sense to add that right here, or is there something else I want to say about? Nope, let's add this here. So TCP versus UDP. What's the major differences?
Reliable
One
versus
can-
unreliable.
TCP is the three-part
Connection
handshake.
oriented? Sorry.
Okay, so a few things. I got requires three-way handshake. So there's the three parts that I requires three-way handshake, and I'll put in parentheses reliable. And I know I heard someone else.
Connection oriented.
Yeah, so this even adds on to that. Three-way handshake, connection oriented, reliable, right? All three of these things are really getting at that same point, that in order to have a socket over TCP IP, we need to do that three-way handshake first, and then we'll send data. Anything else we want to say about TCP? Three-way handshake required.
It will retransmit if packets are dropped.
Retransmit if packets are dropped, which is fantastic. I think that's about all we need to really know for TCP. I guess I'll add that it's most common versus UDP. So usually we're thinking most services act over TCP connections. Some don't, right? Like DNS is usually UDP. NTP, network time protocol, is usually UDP. Cool. So we'll add just kind of the opposites here. UDP is it's unreliable. Shoot out some data. Hope you catch it. We won't check. Useful sometimes, right? Especially in maybe cases where you need really low latency, or you don't really have a lot of bandwidth and you're just going to shoot out data and hopefully someone catches it, right? Makes sense sometimes. You might need that. Okay. As far as basic networking, the default ports for the common things: SSH, FTP, HTTP, HTTPS, SMTP, I don't know, DNS. I think we went through all of those already, but just know them. I'm explicitly going to tell you that. Tools and C, right? Netcat. I'll just say Netcat.
Will the test be open notes and things like that?
Yep. You will have access to the sheet. You will have access to the Google internet, right? Just like real life. Have all that. So what do we use Netcat for?
Open a connection.
What kind of connection?
Listening connection.
A persistent connection.
Can be. But what kind of protocol are we using is what I want to hear.
Socket?
It's a socket. So it is
TCP.
TCP, right? We're making a TCP connection, right? I have a port. So we must be living at the port layer, and we're using TCP, not UDP when we use Netcat. That's what I'm talking about. So we use Netcat to connect to a port, a TCP port. I don't think it has a UDP option. And if it does, we're never going to use it for that. So just so that we see what that looks like, that is, and see, right? What do I type in? What if I want to connect to port? Connect.
USB?
to shell.fullstackacademy.com port 1337. What if I want to do that?
Would it be NC-VLP, and then it would be shell.fullstack academy and then 1337.
P shell.fullstackacademy.com 337. Something like that. Let's find out.
There's also
Maybe no
LKP as well.
I don't think so, because VLP
No
usually
L,
need to put the
because
port
we're
right
not listening.
afterwards. And P usually need to put the port right afterwards. I think you would just do NC in the website, right?
Let's try it. Hold on. Let me. I think I have NC on my host, so I can do it there. NC. Oh, I'm not sharing the screen. Let's share the screen. Make this larger. So if I just try and see shell.fullstackacademy.com, it's telling me needs host name and port. So let's try just giving it the port like this. Nope. So let's try doing what I don't remember who said, but --p. Nope. So what am I doing wrong? I might just be because of my version of nets of that here. Let me get that open. Oop. Unless someone can give us the answer. Who's going to get it first, me or someone in the class? I don't know.
What's the port number?
1337. I actually don't know if that port's open, so it might not. Dude, we get to do a quick demo. Oops. Go away. Let's split this terminal. Vertical. Well, if I wanted to set up a listener on port 1337 on my own machine, what would I type?
NC-L 1337.
Cool. If I wanted to reach out, make that TCP socket connection to myself on port 1337, what would I do?
NC localhost 1337.
Localhost 1337, like this. Oops. I'll try it. Try anything once. Hi. Yay. So we just gotta do that. Hello. How are you? I am fine. It's Friday, guys. Okay. Right. So if we wanted to connect to shell.fullstackacademy, there, we would do that. I usually like adding the -v for verbosity, but you don't need to. Right. Set up a listener on your own machine. And L port number. So let's put port number. I'll put it all in caps so you know it's the variable. Cool. Okay. We're going to be using Netcat a lot more in Red Team. You'll really see why I say it's the Swiss Army knife kind of tool. Very handy. You're going to use it to set up listeners on your machine. You can use it to reach out to other machines, talk to protocols you don't understand, right? It's going to be very, very handy. Cool. Anything I want to add about Netcat? No, I don't want to add any more about Netcat. But how can I tell, right? And this is, I guess, different. So how can I tell what ports are open on my machine? What's that command? I'm on Linux.
Netstat.
Yeah, gotta know netstat. Gotta know netstat. I usually just remember -pant. That usually gives me the information I want. I'm just gonna add netstat like that. Used to determine ports on local machine, right? Netstat dash pant. Super useful. You know, maybe you get on a machine, you want to see what actually is open, what's going on. Sounds good. Useful tool. Not too much more to add on that. Other big tools that we've used that you're going to need to use for the exam are Wireshark. Wireshark, right? Our nice friendly GUI tool. You don't have to use T-Shark, TCP dump, I don't think. So what's important? What are the techniques that we know how to use in Wireshark right now? In Blue Team, we're going to get a lot better at it, trust me. But what techniques do we know to look for things inside packet captures now?
Search packet bytes.
Yeah, search for text in packet bytes, or what is it? Packet data info, or right? Really, just search for text. Let's just add that. Right, that's what you've been trained to do so far with Wireshark. You know, you'll look for your flag, you look for your marks of a flag, like FS curly brace or something like that, and then kind of go from there. So once you find a hit, what's the next thing that you generally do?
Follow the TCP stream.
Follow the stream. I won't say it has to be TCP, but generally it will be. But yeah, you follow the stream, follow this whole connection and see what happens. See if you can uncover who was talking to who about what. Right, follow the stream. And then finally, the other important thing that you guys learned how to do is export files from packet captures. Right, and if you recall, that was just going through the GUI. There's a little menu of export objects. And you grab those objects, right? You found the JAWS flag, very fun. In Blue Team, we'll show you other ways that you can carve out data from PCAPs. But for now, this is all you need to know. Searching for text, following streams, and exporting files. You know, then being able to use your knowledge of OSI model to kind of piece together what happened. Okay, so you can think back to the Cyberlab problems where you needed to either run a binary and have Wireshark capturing the traffic and then, you know, pay attention to what it did, or we give you a packet capture and ask you to, you know, kind of find the flag from within there. Right, both of those things, fair game. Okay. Let's talk encoding, encryption, and hashing. Right, super crucial to security. And there's some nuance in each of these terms. Definitely overlap on all of them, but some nuance in how we talk about each one and what their purpose is. Right. So what is? Do I want two here? Oh, I think I want one. Three. Yeah. What is encoding? Give me the good one-liner.
Changing data from one form to another.
To another. I love it. Simple, elegant. That's what you're doing. Common encoding schemes that we've just learned about. Give me a list.
Base 64.
Base 64, super common. Going to see it all over the place. More.
Hexadecimal.
Hex.
MD5.
Not an encoding scheme.
ROT 13.
ROT 13. ROT 13. Bring it back to the ROT 13.
Binary.
Binary is an encoding. Decimal, so I'll just add that as well. Right, we got
Hashing.
octal. I won't add hashing. Hashing is not going to be encoding, but that's good that you bring it up because you know, I want to make sure that we understand the differences between them. The other one that's big that I think no one mentioned is URL encoding. Someone mentioned it earlier, but no one had mentioned it now. So if you look and you type stuff into your URL bar, you'll see some characters are not allowed. Like if you type space in your URL bar, you have a URL with a space, it gets turned into %20. Maybe I'm wrong. Test it yourself, you'll see. But again, the big thing here is we're changing data from one form to another. If I want to add an extra clause so we can be a little bit more specific, right, is without the intention of hiding things. It's not necessary to add this. I think your answer was already fantastic, but if we want to add some more clarification here and separation between what is encoding and encryption, right? There's no intention of hiding things here. In fact, we want people to understand it on the other side, right? This is also, you know, availability, right? Crucial to the CIA triad, right?
Why are you calling ROT 13 encoding?
Oh, why am I calling ROT 13 encoding? Yeah, it is. It's not encoding. You're right. Because it is intended to hide. Thank you. Thank you for catching me. So let's fix that. Because it's not an encoding scheme. At least it's not a very good an encryption scheme. It's not a very good encryption scheme, but it is usually used for hiding things. So it is an encryption. So that brings us right there. Encryption. Right. Give me a good one-liner.
Reversible method of obfuscating data.
That is reversible method of obfuscating data. 1, 2, 3, 4, 5. 5 words. I think that's pretty succinct, right? A reversible method of obfuscating data, of hiding data.
Should it be occasionally reversible?
Nope, should always be reversible. What?
Except for hashing is not reversible.
Hashing is not reversible, but hashing is not encryption.
Fair enough.
So and right, this is where we get into those it's not really semantics, right? There's a little nuance between each of these things and how they're used and like what they actually do. Encryption always must be reversible, otherwise there's no point to it. Hashing by definition is irreversible. So let's add common encryption. Ooh, before I do that, do I want to say, no, I want to say something else before we talk about common ones. I want to talk about asymmetric. I want to talk about symmetric. What's the big difference between these two?
Symmetric has 2 of the same key that you're sharing across people, and then asymmetric has a private and a public key.
Yeah, so same key, 2 keys, public and private. Right, we take one that we keep for ourselves, one we give to everyone else. If someone wants to send me a message, they encrypt it with my public key, and I'm the only one that can open it because I'm the only one with the private key. Same idea for everybody else. We also have symmetric. This is where the same key is used to lock it up, just like a regular lock and key in real life. Pros and cons of each one of these is symmetric is a bit easier, one to understand. It's a bit faster. Asymmetric requires a bit more, what can I say, infrastructure to actually get going. And in fact, when we use HTTPS, we're using both asymmetric and symmetric. We use asymmetric to get that shared secret, that symmetric key. And then once we have the shared key, we use symmetric, right? So we have to use asymmetric first and then symmetric, right? It's that problem of, okay, we want to do encryption, but how am I going to get my key to you without everybody seeing it? First pass problem. Common encryption. Protocols now, algorithms. Which ones do you want to know? Which ones are important? Give me some.
Substitution.
Yeah, we can do substitution. Give me some here, and I'll give you the ROT 13 Anissa too, because that one goes there. Oops, these should be in a list. Tabs like that. Okay, we got these guys. What are the ones on the internet?
SSH, RSA, DES,
SSH is not, but
RSA, DES.
RSA, I like. DES is one of them. It's not as common. Is it? I think it's triple DES now. Or DES. I forget. Got AES, the Advanced Encryption Standard. Just be familiar that they exist. There's many. There's whole suites of them. Anything else we want to say about encryption before we move on to hashing? Anyone have any comments for it? Okay. Let's go to hashing. Running out of time. Sorry. So we got hashing. And then can I get a one-liner from someone again? Someone different this time. I don't know if it was the same both times, but not that I didn't like it. I love this one. 5 words. So that's short.
The manipulation of data so that it can't be traced. It's irreversible.
I do like it's irreversible. I do like it's
A
irreversible.
one-way method for storing data.
One-way method for storing data, but it's not just used for storing data. So I like it. Let's see if we do better. Come on, keep going, keep going. What's the main purpose of hashing for us? If it helps, I'll add availability, confident.
A one-way method of protecting data.
See, I wouldn't say, so the 2 parts here. I wouldn't say it's for protecting data, because when we hash it, it's not data anymore. We've lost it, right? It doesn't have any, there's no way to go back.
Integrity.
Yeah.
So yes, it's definitely for integrity of data. And I agree, this one is the most challenging one to understand for the first time, like what is hashing. So yes, it is for the integrity of data. And I'd like that we said it is changing data.
Is it a method of storing data in a form that's changed so that it is not obviously like a method of manipulating data so that to the naked eye it's not what it's meant to be? Like, so it's not password ABC is not going to say password ABC.
So you're telling me yes, but that's not. So can you phrase it differently? I guess it's hard. So changing data into, well, let's look at what hashes look like first off. Right. Sometimes it's more simple than we think. Let's close that connection. And maybe it'll make sense if we just look at a couple of hashes. Close you terminal. Echo, hello. Into MD5 sum. Right. Go. Right. Just oops. That extra character is because I fat fingered that. What are we noticing?
So no matter how long or short the string is, you always get the same.
Crucial, right? That's one crucial part, right? So it changes data into something of fixed length. And what else about it?
No collisions.
Shouldn't have collisions. 2 things should not collide. So that's what makes a good hash algorithm. Well, let's talk specifically
It's a
about
letters and numbers.
Yeah, it's pretty random too, right? Pretty random string of letters of numbers of fixed length. If that's, I think, as easy or clear as we say, change data into random character string of fixed length. Same. What's the word for same in? Always is the same out. Same input always yields same output. right? I want you guys to be aware that hash algorithms, they don't do anything. I mean, they're kind of cool mathematically, but all they do is take data and turn them always into a random string of fixed length. That is what the whole job of the hashing algorithm does. It's kind of like taking a fingerprint of a file in a way. And they're set up, right? A good algorithm. Good hashing algo has these properties. Someone said it before. Could you just repeat what you said about collisions? Or what is a collision? Or if you're speaking, you're muted.
Two text will never yield the same MD5.
Yeah, so two inputs should not yield the same output. So, oops, no, go here. No collisions. Different output, same, or different input, same output. Right, that's a bad thing for our file integrity, right? It's like if two people had the same fingerprints, that's not great for, us doing things like that. And then you guys already mentioned it, right? That it is commonly used for storing passwords. And then I just want to add the common ones. Common hashing algos, MD5, SHAs. There's like SHA-1, SHA-2, SHA-256. That's all. That's as far as you need to know. MD5s and SHAs. Okay, that's about as all I want to talk about hashing. Used for integrity, fixed length, no collisions. Okay, almost there, I promise. Compilation versus interpretation, right? All the way back to day one, we first started about programming, right? So some programming languages need another program called an interpreter to interpret, to run, or really to change the source code into byte code that the machine can actually understand, right? We write Python, machines don't understand Python. The Python interpreter takes our commands, takes our Python that we write and turns it down into low, byte code versus, we have compiled languages. They use a program called a compiler, change source code into byte code. Very similar sounding, doesn't it? Byte code. Why did I write sound? We're going to use an interpreter. Compiled languages need a compiler. This will make more sense when we actually start using some compiled code. In Red Team, eventually you're going to have to, you'll find some scripts that are in a language that needs to be compiled, and then you need to compile it for your target. So what do I want you to do for the exam? All I want you to do is know examples of compiled languages, know examples of interpreted languages. You should know the big ones, right? You want to know that. So C, compiled language, Python, interpreted language. Right? You want to be familiar with these. And then finally, just some basic stuff here. I wouldn't want to make sure we cover all the bases. You're gonna, of course, need to know how do you move things around, move around the command line. So we'll cover everything: navigating, file system. What else do we need to do for basic Linux things? File creation, modification, deletion. Should be able to do all these things, right? And feel comfortable and strong doing them. No relative versus absolute path, right? We should be aware of what those differences are. know how to view and change file permissions. Know how to view active processes. Let me add this right below here. Know how to change permissions for users. And I think that's all we've learned in 2 weeks. Well, not all we've learned, but at least we've touched on everything we've learned in the past 2 weeks. Does anyone have any questions? I mean, I'm sure you do.
So are there going to be any bash scripting in there?
There will be CyberLab problems. I don't think you will need to really write anything long. You'll have to use bash, right? Just like you have to use the command line, but I don't think it's absolutely necessary to write any bash scripts like we were writing today. That gives me a good point. Let's talk about what's actually on the exam and how it's broken down. So we have 10. Let's do this. Exam breakdown. Let's actually put this at the bottom. That's not the most important part. The most important part is the content. The test is just how you prove that you already learned it. So the exam breakdown, we're going to start off. It's part HackerRank, part learn dot. The HackerRank part, and then I should say part CyberLab. So 3 parts. The first part will be 10 multiple choice questions related to all of the stuff we're talking about here. So, questions about HTTP, questions about different protocols, etc., like that. 10 multiple choice questions. It's open book. Okay, and this is 10%. Cool. 1 point a question. Great. Next up. 7 of 10, your choice, CyberLab problems. Okay. The way this will work is it'll be like the Linux exam you guys took in Foundations, where inside the HackerRank exam, there will be a flag that you put into CyberLab. And from, once you have that flag, it will unlock the problems for the exam. Inside HackerRank, you will see problems that have the same name as the problems in CyberLab. You take your flag from HackerRank, or excuse me, from CyberLab, you paste it into HackerRank, so it actually gets graded. So the process is, you pick the question you want to do, you solve it, great, you get your flag, you confirm the flag works by putting it into CyberLab. To actually get your points, to get graded, you got to take that flag and you got to paste it into HackerRank. So you've done it before, just refreshing your memory. That's just how you'll get graded for those points. 7 of 10, your choice, 70%.
Matt?
Yes.
Do we have to use the provided Kali Linux, or
You
we can use the
at this point, you
2020?
use whatever you want. Whatever you want. It should have the tools that you need for doing these things, though, right? Make sure, you got to have curl, you're going to need Wireshark, you need a browser, whatever you do, use what you want, but you're going to need these tools that we've been working on for the week. Okay. But sure, you want to upgrade to 2020.4, go ahead. And then finally, we have 3 Python problems. I think it's actually 2, and 1 is bonus. And these are worth 20% plus bonus. I think the bonus is a small amount. Bonus might be like 3 points, and the problem is kind of challenging. It's not too challenging. I think some people can get it. I think so. I think you guys can get it. But that's the breakdown of the exam. Questions on that?
What's the time limit?
Let me double check. Frank, are you here?
Yeah, I'm here.
We have it on the calendar. I just want to make sure that, because I'm looking at the calendar, I want to make sure that the calendar is what we're doing.
Well, HackerRank has the timings.
All right, let me go into HackerRank. Double check. I think we usually do what, 4 hours?
It's been 3 or 4. I can't remember what we decided on.
Essentials. We're running A or B.
Shouldn't matter in terms of time, I think.
One says 2:30, one says 3:30. I'm not sure why. So let's say 4 hours then, because that's what the schedule says, right? Let's go look today. From 10 to 2:30, 10 to 11, 11 to 12, 12 to 1, 1 to 2. So you have 4 hours plus 30 minutes for any other hiccups. Does that sound fair to you, Frank?
Fair.
All right. See, look at it. I'm fighting for you guys. I got you the extra hour. Frank, I don't know if he would have given it. All right. Any other questions?
Okay, so the multiple choice questions are going to be on LearnDot.
Those will be in HackerRank. Good question. Multiple choice questions in HackerRank. CyberLab problems. Put your flag into HackerRank after you confirm on CyberLab. Like once it says, yay, confirm, solved, then you can, know that flag is good, put it in. And then the Python problems, these will be in learn.upload to run code like you have been.
Okay.
Those nested parens.
Okay, so the test is going to be Tuesday. So we're going to use Monday again to review?
Yep. So Frank and I plan to both be setting, and all the fellows to be setting office hours for one-to-ones, as well as keeping the breakout rooms open. So if you guys want to have your own study sessions or go over problems in specificity, either me or Frank will be in the main room.
Yeah, and then we'll go over specific problems like as in depth as we need to bring the point home.
Can any of you talk about the testing environment? Like, what does it look like? Do we get a break in the 4 hours, or are we all like in a big Zoom room all on mute? Like, what is it like?
You'll be in your own Zoom room. There will be no breaks.
Yeah, we won't take any, and you're not going to be able to move. We'll manually assign you. So no one can come in except us. No breaks, but if you need to go to the restroom, right? No one's saying you can't.
Yeah.
But
It's
just that time. You have that time from 10 to 2.
For the Python problems, is there any way that we can, like when we upload it to run the code, is there any way to check to see if the code is correct?
So we'll manually go through it because I know.
So run code gives you back a message. But we will look at the code that you upload as well, so that if you're like positive that it's right and it's working, but run code isn't giving you a success message, we're going to look at the actual code and see if you got it to work, if you've answered it correctly. But so I guess the answer to that is kind of, right? Run code does give you a success or like a thumbs up, thumbs down on whether your code works successfully, but we have seen instances where sometimes that thumbs up isn't as thorough as we'd like it to be. So we will go behind it and look manually.
Yeah, we'll manually check the code.
Will there be anything that we need to submit over the weekend for homework officially, or is our homework studying for the test?
Great question. Yes. So let me share this last thing with you. I think it'll be pretty self-explanatory and pretty fun because you've mostly done all of the work already. So let me share this out So you're going to get access to another repo. Ba-ba-da-ba. This one's weekend number 2, and the instructions are here. So just so I can quickly go through with you. I have here a list of CyberLab problems. These problems specifically from these sections. These are the problems I recommend you go home this weekend and you redo 2, 3, maybe even 4 times, right? Once you speed run CyberLab for these past 2 weeks to see how much better you are at these things, specifically because the questions on the exam are going to be very similar to these. So, I want you to be comfortable with those problems. Now, what do you have to do for homework? Well, as you're studying and going through these problems 2, 3, 4 times, I'd like you to start practicing and writing write-ups. This will help you once we go through PWK. It's a requirement for the OSCP that you write a write-up for each of the boxes that you solve when you take the exam. And, we're trying to get you familiar with what does a write-up even look like. So we've given you an example. You'll see here, here's the README that you're looking on that has the instructions. Here's the example. We want you to do 10 of these from this list, your choice. And so what does a write-up look like for us, right? It's essentially just the solution. What did you need to do? The student put in a screenshot. You don't have to. You can just copy and paste exactly the command that you wrote. And what's important though is that you're explaining, right? We use this option. Why did we use this option? We use these options. Why did we use these options? I want you to be as explicit as possible so that my youngest brother can read your solutions and do it. I want you to start being able to write like you're writing for an idiot. I don't mean that. I mean that kind of as a joke, but also because it's a very good skill to be able to write things that almost anybody can understand as explicit as possible, especially so in IT and in security. So this is our way of getting you to that. You'll have access to this repo. What you'll need to do, same as last time, is while it's under Full Stack Academy, you hit the fork, you bring it to your own account, and then you clone down and make any changes to the repository you want to make. Again, the instructions will be here. And you can work on this with other people, but it's just important you have your own repo and your own solutions that you've written. That's all we're looking for. Cool. Questions?
Well, I have a question, but it's not exactly related to the exam. It's for PWK. So we were supposed to sign up for the earliest available date, correct?
For the exam?
No, for the actual PWK lab. The
Yes.
Right. So